So welcome back. So we are going to introduce the concept of differentiation. First, by defining a derivative, and then using definition of a derivative to find or to carry out differentiation. So derivative definition. So the derivative of a function f of x is another function f prime of x given as f prime of x equals to limit as h approaches 0 of f of x plus h minus f of x divided by h, provided that this limit exists. That's how we define a derivative of a function f of x. So I'll call this definition 1. Let me know when to proceed. Okay, good. So so let's define the term differentiation. So the process of finding the derivative of a function is what we call differentiation. The process of finding the derivative of a function is called differentiation. So we can also define derivative with respect to a specific value of x, derivative at a point. So the derivative of a function f of x at a point x equals to a is another function. Oh, it's a number. F prime at A given as F prime at A is limit as h approaches 0 of f a plus h minus f of a divided by h, provided that this limit exists. So when this limit exists, we say that f is differentiable at x equals to a. So this we are referring to this derivative at a point. So when this limit exists, then we say that the function f is differentiable at x equals to a. While in the other case, when one limit in one exists, then we simply say that the function is differentiable. So note when derivatives of a function are obtained using definition 1, we say that we are differentiating by first principle. So when you use limits to find derivatives of functions, we say that we are differentiating by first principle. So before doing any specific example on how to carry out derivatives, we're also going to define what we call tangent tangent line to a curve. So assume that a function f of x is differentiable at a point x equals to a. Assume that f of x is differentiable at a point x equals to a. Then the tangent or simply tangent line to the graph of y equals to f of x at a point P is the line through P of slope f prime at a. Its equation is given by y minus f at a is f prime at a into x minus a. If you remember from your high school work, we say that simply a tangent is a straight line which touches the curve, which passes or touches the curve at one point. That was from simple interpretation. Like if I have this as my curve, then a point P whose coordinates are a comma f of a, if this is a graph of y equals to f of x, is this line that only touches P at that point. So we call it tangent or tangent line. Okay, let me test whether you still revise your high school work. A line which is perpendicular to the tangent at P is called? If I have another line that meets this tangent at 90 degrees, what name do I call that line? It's called normal. So normal is a line which is perpendicular to the tangent to a curve at a point. Line which is perpendicular to the tangent to a curve at a point. And in Math 125, we discussed how to find equation of lines and also discussed how to find equations of perpendicular lines. So which means that you should be able to find the equation of tangent at a point and also the equation of normal at the same point. Because the point remains the same. What varies is the slope. And slope, you know that the product of gradients or slopes of two perpendicular lines must always give you product M1 by M2. That's for parallel, but these are perpendicular. So we know that for perpendicular lines, yeah, so for perpendicular lines, the product of gradients is -1. M1 by M2 is -1, where M1 and M2 are slopes. So which means if I know that the slope of the first line is f prime at A times M2 equals to -1, then what would be the value of M2? -1 over f prime at A, okay? Yeah, so which means equation of the normal at P is y minus f at A equals to -1 over f prime at A into x minus A. So you don't have to worry with this expression. So we'll do examples to illustrate how to solve or how to find tangents and limits. So you let me know when to proceed. Good. So let's now do examples on how to find derivatives from definition or from first principle and see how to compute equations of tangents and normals. So let me call them exercises. So use definition to find the derivatives of the following. So A, the function is f of x equals to 2x plus 7. So remember, when we say use definition, is the same as use first principle, which simply means getting the derivative using limit definition. So solution, we'll say here, f of x is given by 2x plus 7. This is what is already given in the question. So what will be f of x plus h? This implies f of x plus h will be given by So this f of x is 2x plus 7. So what is f of x plus h? Remember what we started with in this topic when you are studying functions. If you are given f of x is 2x plus 7, what is f of x plus h? The same. Okay. Okay. Hello. Yes, Agnes, what are you getting? Plus h. Okay, please, I remember the analogy we used, that you take functions as machines. So this machine, you give it x, it gives you 2x plus 7. What happens when you give it x plus h? Okay. Yeah. Mm. Mm. Yeah, so which you can simplify to be 2x plus 2h plus 7. Okay. Yeah, if you use that analogy, it will always be easier. It will be easier way to deal with functions. Take them as machines. You give them inputs, it gives you outputs. So it follows the same operation. So you give it an x plus h, it will then take that x plus h multiplies by 2 and then adds constant 7. Okay? So we know that the derivative of a function is given by limit as h approaches 0 of f of x plus h minus f of x divided by h. That's what we call derivative by definition. Okay? Yeah. So what happens now is just to put in the value we have as f of x plus h, subtract the value we have for f of x, and then divide by h. Then simplify things here and there, and then carry out the limit. So this will be limit as h approaches 0. So where this f of x plus h, you put 2x plus 2h plus 7. You subtract where there's f of x, 2x plus 7. Yeah. Remember to use brackets so that you don't mistake with signs. It's one number here, one thing. Okay? Yeah. Then limit as h approaches 0 of 2x plus 2h plus 7 minus 2x minus 7 over h. Are there things which will cancel out? Yeah. 2x and 2x. At the end, 7 and minus 7. Okay? Yeah. So this gives us f prime of x is limit as h approaches 0 of 2h over h. What is 2h over h? 2. So this will be f prime of x will be limit as h approaches 0 of 2. And what do you get? 2. Yeah. Yeah, limit of a constant is a constant. You're just correct. Yeah. Limit of a constant is always the same constant, regardless of where the variable is approaching to, okay? Yeah, so that's the answer to that question. B, f of x is given by x, 2x squared plus 4x plus 10. Tell me when to start. Good. So solution, the first thing you say that f of x is given by 2x squared plus 4x plus 10. The function is already given in the question. Okay. Then from that, define f of x plus h. 2 into, yes, then plus into, and then, yeah, so that's the first step. Replace to the role of x is taken by x plus h. Then open the brackets. We'll have 2 into x squared. I trust you can do that expansion. Eh? And then plus 4x plus 4h plus 10. Eh? And once you have done with that, open the brackets. So 2x squared hx plus, and then x plus 4h plus 10. Good. So don't be scared by the length of the expression. So that's what we have. Now, we know that the derivative by definition is limit as h approaches 0 of f of x plus h minus f of x divided by h. That's by definition. So we are going to pick our f of x plus h, then subtract f of x and divide by h. So f prime is limit as h approaches 0. So we have 2x squared plus, and then plus 4h plus 10. I want to trust that you understand that when you say minus f of x, each of the term for f will have a negative sign. Yeah, so minus 2x squared minus, yeah. So you understand where the negatives are coming from. Good. So 2x and minus 2x, Any other term to cancel? And then any other? 10 and 10. So then now we'll have f prime of x is limit as h approaches 0 of 4hx plus 2h squared plus 4h divided by h. Okay. So remember, we are dividing h by each of these terms, so we can factor out h in the numerator. So limit as h approaches 0. So h into 4x plus 2h plus 4 divided by h. Yes, h and h cancels out. So we'll have limit as h approaches 0 of 4x plus 2h. Or plus 4, yes. At least now you are very careful, so that's what you expect it to be. So plus 4. Now, this is what you are doing in the previous sessions, how to find limits. So what will be the value of that limit? The limit of sum is the same as? Yeah, so because remember in this, when you are evaluating this limit, the variable is h. Anything that is not h is treated as a constant. Yeah. For x. And then plus 4. So finally, correct. So that's what we have. And then that was B or C? B. So C, f of x is given by 1 over square root of x. So the structure is the same. In this case, f of x is given by 1 over square root of x. Then this will mean f of x plus h is correct. That's what it will be. Just the role of x is taken by x plus h. Then we know that to find the derivative, f prime is given by limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay? Yeah. So which means we are going to have f prime of x is limit as h approaches 0 of 1 over square root of x plus h minus 1 over square root of over h. Yeah. Is it possible to cancel h? Is it possible? Is it possible to cancel h? Yes. Yeah, so the easiest thing, let's put the numerator as one fraction. So we have 1 over square root of x plus h minus 1 over square root of x. So the LCM is not really, just the product of these two. So square root of x times square root of x plus h. So this into the square root, into the LCM. Square root of x minus x minus h, okay? X plus h, okay? Yeah. So we have, or maybe even the other way of, okay, so that's what you have. So then this, does it really help us to simplify anything? In that case, is it even making our work easier or is making our work even harder? Okay, let's see. So square root both sides by So okay, let me see what you're saying. So you're saying instead of doing this, we multiply the this expression h. So remember what you do. What you do should not read. What you do should not interfere with the fraction itself. Huh? Yeah. So it shouldn't interfere with the fraction itself. So in this case here, so we are going to have this as so square root of x minus square root of x plus h divided by square root of x. Then okay, so let me just write that x plus h, and so I remember I have to divide everything here by h. So we are dividing this by h. So if I'm multiplying by h is like 1 over h, okay? Then, so let's see how the h is going to cancel out. Now, another way we can rationalize the numerator. Okay? We can rationalize the numerator here. Or maybe even at this stage here, where we have f of x plus h minus f of x. So we have this expression here, 1 over root of x plus h, and then 1 over square root of x. We can as well rationalize that each term differently. Okay? So this will give us, so square root of x minus square root of x plus h. So what is the conjugate of this? conjugate of this, you simply change the sign to plus. Do you remember how to, if you are given, say, root 2 plus, say, root 3? So if I give you 1 over root 2 plus 1 over root 3, so how do you rationalize this? You multiply root 2 by root 2 minus root 3, and then this is root 2 minus root 3. Okay? Do you remember this process of rationalizing the denominator? Okay, but you also did this, we also did this when you are doing the limits. You remember where we had they had a limit of this form, say x approaches 0 of square root of x plus 1 minus 1 over x, something of this kind. So where we were rationalizing both the numerator and denominator. Okay? Yeah, so what we do here, so our interest is to reduce this expression 1 over square root of x plus h minus 1 over square root of x. Okay? So we started by saying LCM is this time this one. Okay? And then this into LCM is square root of x minus how do you understand how that is obtained, okay? And then you see we have to divide this by h, but you see the structure of this expression here. The structure of the expression here is not allowing us to do the division by h. Remember, the only reason, the main reason as why we are struggling is because the limit is h is approaching 0. So if you do direct substitution, we are getting a 0 in the denominator. So that's what's making us to play with this function such that we have a point where h will be canceling out. Okay. Yeah. So if I rationalize the numerator, I multiply, so I only change the sign here. It's minus, then it becomes plus, okay? Okay? Yeah. So this is what you have. So which means we have like a minus b, a plus b. What's the expansion of that? A squared minus, no, just a squared minus b squared. These are difference of two squares. Okay? Yeah. Difference of two squares. So Our new numerator will be one. Why one? So what is your a? If you relate this to what we have here, a becomes which value? The square root of x, and b? Which is? Okay, let me just write it. Root x squared, which is just x, okay? Just x minus, yeah, x plus h, okay? And then this is divided by root x plus h into root x plus square root of x plus h. We need not to open the brackets. Okay. So what will be the value in the numerator? H, but negative, negative h. So over square root of x plus h into root x plus root of x plus h. Okay. So when you divide this by h, you are sure that you will not have it in the denominator as one term. So it means that 1 over root x plus h minus 1 over root x divided by h will be given by 1 over h times this value here. Okay? So remember, when you say a minus b over c, it's like 1 over c times a minus b. Okay? Yeah. So negative h over root x times root x plus h into root x plus root of x plus h. Negative 1 now will be the numerator, okay? Yeah. Yeah, so negative 1 over the expression root x square root of x plus h into square root of x plus square root of x plus h. So this is what is giving us the f of x plus h minus f of x divided by h. Okay? So the derivative f prime, which is limit as h approaches 0 of f of x plus h minus f of x divided by h will be simply the limit of this expression now, okay? Yeah. So the limit as h approaches 0 of negative 1 over root x plus h root plus, correct. So there the direct substitution must always work because we have done some simplification. Yeah. So where there's h, we put a 0. Negative 1 over root x plus 0 into root x plus 0, correct. So this will be -1. So root x by root x. Okay, so let's just simplify what is outside. Okay, it's like asking you what is square root of 5 times square root of 5. Is 5. So root x times root x is x. So this will be -1 over x. Now root x plus root x. 2 root x. So which is simply -1 over 2x root x. And if you are to put those values to the same power, so remember we have x, when I don't have a power, it's like x power 1. And then root of x means x raised power 1 over, yes, power. So remember, square root of a number from March 120 means a number raised power half. Okay. So root of x is the same as x power half. So what will be the new power of x? So loss of indices. X power. Yes, 3 over 2, okay? Yeah. So you can write your final answer as -1 over 2 x raised power 3 over 2. Do you have some idea on what you are doing in high school on differentiation by power? Where you drop the power and then subtract 1? So remember, this is the same as x raised power -1/2. So if I drop the power, I get -1/2, and then subtract 1 from the power. So don't worry, we'll see it. We'll remind you. Okay? Yeah. But the way we have done this question is it can scare people that this process is very hard. Or are you comfortable? Okay, good. Okay, if you are comfortable, okay. Now, but remember, we can simplify all this process by redefining equation 1. So note 1 is f prime of x is given by limit as h approaches 0 of f of x plus h minus f of x divided by h. So let me pick a different number, say z, be given by x plus h. Okay. You pick this x plus h to be a different variable, say z. So this means as h approaches 0, z approaches. So when you say as h approaches 0, it's like when you replace h for 0, what will be the value of that equation? Sure. If I put 0 here, z approaches x, okay? That's the implication of that equation when you say h is approaching 0. Now, from that, what is the value of h? If z is x plus h, then h is the same as? Huh? Make h the subject. Z, z minus x, okay? So you can rewrite this definition using variable z. So this is the same as, so this definition is the same as f prime of x will be limit. So instead of saying h approaching 0, then you say z approaching x. Okay? So this implies this, or is replaced by that. And then where there's f of x plus h is given by z. So you write f of z. And then you leave this one the way it is, f of x. And then h is the same as z minus. Yeah. So this is another way of redefining the same definition in one. So this has the same meaning as what we have in one. So the question we had as f of x equals to 1 over root x. Then this will mean f of z will be if f of x is 1 over root x, then f of z is okay. You are given the minute, no problem. So if this is f of x, what is the implication for f of z? If f of x is 1 over root x, what is f of z? I'll never tire to remind you that we are taking these things as machines. Eh? Yes. Yes, we'll connect it to this definition here. That's why I'm looking for f of z. Yes, 1 over root z, okay? So which means then we have all the values to replace into this expression. So we say f prime of x will be limit z approaches x. So where there's f of z, I put 1 over root z minus 1 over root x divided by z minus x, correct? Okay? So we play with now with this expression. So 1 over root z minus 1 over root x. LCM is root z times root x. So which is the same as root minus, correct, root x minus root z. And then, so this can be written as negative of root z minus root x. Do you agree? Do you agree with that? Yeah. And then when we write z can be written z minus x can be written as root z squared minus root x squared. Yeah, which is the same as root z minus root x into, yeah, so difference of two squares, huh? Yeah. So you can now rewrite this part using these expressions here. So which will be limit as z approaches x of now. So remember, this is what we have divided by this. Yeah. So negative into root z minus root x over root z root x. So when I'm dividing, it's like I'm simply multiplying by minus root x times this other expression, okay? Okay, so let's not mix steps. So let's just say 1 over z minus x. Huh? Yeah, we have written it in terms of this root so that they will cancel with some of these expressions. Yeah. So f prime of x is limit as z approaches x of negative of root z minus root x over root z root x into root z minus root x into, correct. So some things will cancel out. Eh? Yeah, those will cancel out. So we can factor out the negative sign. Eh? This negative, okay? Yeah. Okay. So there's no problem. So when if you have one negative sign, whether you put in the denominator or numerator, doesn't matter. Yeah. But in fact, actually, so you can actually introduce that negative either with this expression in the denominator or in the numerator, whichever. Just to help you to have some common bracket that you cancel out. Okay. So x is approaching, z is approaching x. So which means that where the z will replace by x. So I'll have root of x into root of x plus root of, yeah. So which is negative 1 over root x by root x is x into 2 root x. So in fact, you can write your answer as -1 over 2x root x. Okay? Yeah. Or the way we have written it earlier. So just to be sure that you have understood what is happening, can you deal with this? Or we do it together? Okay, yes. Fine. Whichever method will work. Use use search approach as 0. All of them are the same. So pick one that you like. So which formula have you decided to stick on? H approaches 0, okay? Yeah, so this is already given. So we need f of x plus h, which should be the square root of x plus h, okay? Yeah. So the derivative is limit as h approaches 0 of f of x plus h minus f of x divided by h, okay? And then this will be limit as h approaches 0, square root of x plus h minus square root of over h. So how did you move from here? Is a problem. Yeah, so we are interested in seeing how to simplify square root of x plus h minus square root of x divided by h, okay? Now remember, we can rationalize the numerator, we can also rationalize the denominator. So let's multiply each term in the numerator and denominator by the conjugate of this. So what we are doing here is rationalization of numerator. Yes. Are you worried with the numerator itself after multiplying by that term, the structure of the expression? Yeah. So just remember, it is of the form a minus b, a times a plus b, which must always give us a squared minus b squared. Yeah. X plus h squared. Oh, so if you have to put a square, we put a square root. Eh? Yeah, so we'll do that. Okay. Okay. So let's just simplify at once. Eh? So so when you simplify, that will give us x plus h minus x, because it is a squared minus b squared, okay? Divided by, you don't have to open this. Okay. Numerator will be h, because x and minus x cancels. Eh? So what will that simplify to? H cancels out. So remain with 1 over root x plus root. Correct. So which means then f prime will be limit of this quantity, okay? Yeah. What should be? Over. Okay, so for those who are not in, we can be fair to them to replace the 0 before you do the final answer, what you're saying. So then plus root x remains to be root x, okay? So you're saying we'll have root x plus root x, which is 1 over Correct. I hope now you should be able now to apply the first principle to solve the derivatives. Okay. Okay, let me see whether yes or no. Now, what is the derivative of f of x given by k? K is a constant. Yes. Yes, I want the method we are using by limit. Now, you're able to see my screen also. Yeah. So f of x is already given. Okay. Yeah. So what is f of x plus h? Hmm? A plus h. I've catched you. I've catched you. So these are still machines. So these are machine. You give it an x, it gives you a constant value k. What happens when you give it x plus h? Huh? Mm. That one I've catched you. You see these constant functions. If I was to draw this, I'll draw this graph. Okay. So there's no change regardless of the value of x or p. So when you give it x plus h, So like here was 2, then here is 4. So f of 2 is given by k. What is f of 4? Yes? Or do you need St. Peter's to tell you that? So f of x plus h. So the value is k. So remember, constant means that it doesn't change regardless of the input you give it. Okay? So f of x plus h remains with k. So which means our f of x plus h minus f of x will be given by k minus k. Okay, so or you want us to divide by h. So that will be k minus k, 0 over h gives you 0. So which means then f prime will be limit as h approaches 0 of f of x plus h minus f of x divided by h. But from our computation, we have found that this quotient is 0. Okay? So limit as h approaches 0 of 0 is 0. And so that's why we say that the derivative of a constant is always 0. So the derivative of a constant is always 0. So know that dx of a constant value will always give you 0. Yeah. So I state other methods of carrying out differentiation. Mm. Mm. Oh, but even if I don't put this word constant, it will still make the same sense because we say the input I'm putting here is x, but I'm getting k. So there's nowhere x is being affected. Yeah, you say this is f of x, I get k. So remember to do direct substitution mean that the output is in terms of that input. So that's when we replace when we have a different input. But if the output part has no resemblance with what was being inputted, then they remain the same constant. Yeah. So I'll pause the examples on finding tangent and normal to these kind of problems on how to find the equation of tangent and equation of normal. We'll discuss them as we discuss different methods of differentiation. Okay. So let's take the methods and probably have a break. So methods of differentiation. So what we have been doing so far is what we call differentiation by first principle or definition. Can just take it. Differentiation from definition or what we call first principle. So when a question say that find the derivative from definition, is the same thing as first principle, and what the question simply means, you find the derivative using limit definition. And then 2 is what we call power rule. And power rule states that if y is given by x power n, where n is any real number, then dy dx, which is the same as f prime of x, you drop the power and then subtract 1 from the power. So e.g., if I ask you if y is given by x power 2, then dy dx is the same as 2x. If I tell you that y is given by 4x power 3, then what is dy dx? 12x squared. You know you knew these things before. Yeah. So things which are obvious remains to be obvious. If I have x power pi, then dy dx will be pi x. Correct. Remember, pi is a constant. And you do this, or if we have, say, y equals to square root of x, dy dx is so you just remember that a square root means a number raised power half. Okay? Yeah. So when you drop the power, a half x power. So you are subtracting 1 from the original power. Negative half minus 1. Yes. Remember the same thing that you can write as a half, then x raised power half, which is 1 over 2 put x. We have already done this one before. Yeah. So is it hard to apply power rule? No, we simply drop the power, subtract 1 from the original power. 2. Yeah. So product 2. Yes, 3, okay. Product rule. So if y equals to f of x is given by u times v, where both u and v are differentiable functions of x, then dy dx, which is the same as f prime, is given by u prime v plus v prime u. So u prime means du dx, and v prime means dv dx. Because of George, I'll stop there. I'll stop there so that tomorrow, when we meet, we'll give an example on product rule and then state quotient rule, and then next rule is what we call chain rule. And then the last two, we have implicit differentiation and logarithmic differentiation. But I cannot go beyond this. It will make a lot of noise. Okay.